my channel, Science and Technology. Yes, you guys heard it right. We have given a change of name from Science Tutorials to Science and Technology. So who are new here, we welcome you. And also subscribe to my channel. You can find the red subscribe button below the video. Hit that and also hit the bell icon along with it. And now let's discuss what BFS and DFS are. BFS and DFS are basically graph traversal methods. BFS stands for breadth first search. Here we traverse the graph in levels or layer. As I have shown aside is a graph which is having three levels. Level 1, level 2 and level 3. So here we traverse the graph in levels. It is similar to the level order traversal in trees. But graphs have cycle where nodes can be revisited. Right? Here there exists a cycle 2, 3, 5, 4 or 2, 4, 5, 3, however you want to call it. So there exists a cycle. If suppose you started from node 2. In this cycle you visit 3, you visit 5, 4 and there are chances of revisiting 2. So to avoid that we would be using an array of the type boolean. So if you haven't visited if you haven't visited the node yet, then it would be false. If you have visited, we convert it into true. Okay, so I'll just give you the pseudo code over here. BFS node. Let the letter Q be Q. Then Q.NQ node. You put in the node. You NQ the node. Then visited node is 1 because when you come to 1, you make it 1. Visited node is 1. That is true. Mark as visited. Now while Q is not empty, make the node is equal to Q.DQ. That is remove the node N and then visit its neighbors. For all neighbors W of N, if the node W is not visited, then you NQ the node W into the queue and then mark the node W as 1 in visited array. So this is just the pseudocode. I have given the pseudocode for your understanding. The other codes in C, Java, C++, Python are already available in Google. Applications. For unweighted graphs, minimum spanning tree can be found. Peer-to-peer networks, we can find all the neighboring nodes. That is, in a peer-to-peer network, we can find the neighboring nodes from one node. In search engines, we can build index using BFS, that is the crawlers concept. Then we can find new people in social networking sites with a given distance k using BFS till k levels. When you have k levels, you can find people with a given distance of k. So basically from node 1, you traverse to node 2 and then 3 because it's in the level 2. And then we move on to node 4 and node 5 in the level 3. So after traversing nodes in level 1, we move on to level 2 and then level 3. These levels can also be called as layers. Moving on to DFS. DFS stands for depth first search. These are similar to depth first traversal of a tree. In tree there do not exist any cycles as I had shown, but in graph there exist cycles. So there are chances that we revisit the node as in BFS. To avoid revisiting of a node, we maintain an array visited which is of type boolean. So when the node is not visited, we can mark it as not visited by making it false or equal to 0 or anyways, and then after you visit the node, we can mark it as visited with a 1. Again, I'll just run through the pseudo code to understand the main concept. We can write the code in any language once we know the concept. So DFS of node, stack S, we maintain a stack S which is initially empty. So for each vertex U that is present in the graph G, that is vertex is a node. So visited of the node is equal to 1. You are marking the node U as 1 because you just visited. And then you push the node U into the stack S. As I had said, initially the stack S is empty. So as in when you traverse the vertex, you are pushing in the element into the stack S. So while S is not empty, let us pop the elements. from S. That is you you pop only one element. So if not visited, that is if the given node U is not visited, then we'll mark it as visited in the visited array. That is by making the value of visited U equal to 1. Then for each unvisited neighbor of neighbor W of U, that is, let's consider the node W is a neighbor of U. Then even if it is unvisited, only when it is unvisited, not visited, then you push the node W into the stack S. Okay. And yeah, in the loop, you would be traversing all the nodes in the DFS manner. Moving on to applications of depth first search or depth first traversal in graphs. In a weighted graph, depth first search DFS produces a minimum spanning tree. It can also produce the all pair shortest path. Okay, all pair shortest path would be obtained by moving on or traversing on the edges which is having lesser weight. To detect cycles in a graph, as we know that we do not revisit the nodes in a cycle. We use the Boolean array, isn't it? So we can detect a cycle in a graph with the same logic. It is also used in topological sorting for scheduling jobs. Scheduling jobs comes under OS. So in operating system, while we schedule the jobs, we use DFS for topological sorting. Then to test if a graph is bipartite or not. Moving on. Solving puzzles with one solution such as mazes. Okay, so these are the applications for DFS. I have also mentioned a few applications in BFS. If you know more, do comment in the comment section and also like the video and share it with your friends. Thank you. Bye-bye. Please do subscribe to our Science Tutorials channel and also press the bell icon to get more instant updates immediately.